At recording in progress. At the beginning of inference for an intro stats course. And this is based on an activity in the Investigating Statistical Concepts Applications and Methods, the fourth edition by Rossman and Chance, and then some further discussions and suggestions from Dr. Chance. So I'll kind of get into it here. It's looking at 98.6 degrees Fahrenheit, and the question that this is all based around is what is a healthy human body temperature? So let's have a look here. Let's see. So this was kind of the hook for the students, is this 98.6 degrees Fahrenheit is one of the most famous numbers in science, but it's also probably wrong or has changed over time. And it's nice to start with a number that most of them recognize, and it feels like it has some authority to it. And then we kind of challenge that, right? So um, that brings some questions to mind. Like, first of all, where did that 98.6 degrees Fahrenheit come from to begin with? So we can explore that a little bit in kind of the introduction of the project. Uh, what would it mean to test that claim to see if it's different or if it's changed over time? And then in this particular one, as we'll see later, um, what happens when the way you take measurements to collect your own data maybe differs from how that original data might have been collected when that claim was first established? So, what this one was, it kind of served a few purposes. It was a first Minitab assignment for these students. So I was walking them through how to work with Minitab as this went along. Um, I wanted them to do two things kind of at once, look at inference, since that's what we were covering in class, but also work in a little bit about measurement and bias, things like that. And one idea about working in this measurement that kind of happened as I developed the project was to make it seem a little bit more than just like an extended homework assignment because they were already doing, inference and things in class. And so this kind of added another little detail for them to consider some. And then I'll talk a little bit, I kind of already did, but I'll talk a little bit about how this project fits into kind of the stat course as we go. All right, so I'll show you some snippets of the activity here in a bit, but just to give you an idea of how it went, it kind of had three parts to it. So the first part is actually looking at a 1992 study that considered whether that 98.6 degrees Fahrenheit is still a good number to use as the mean, body temperature for healthy humans. And so what we do is we take the summary statistics from that old study and then, kind of rerun that and see what results we get. So they get to look at a previous study and kind of play around with that a little bit. Part two, we collect our own data in class. We take the temperatures of the students, and I had 15 students. So I'll tell you a little more about that in a moment. And then they run it again, but with their own data and see what results they get when they try to test that claim of having that mean body temperature be 98.6 degrees Fahrenheit. And then in the last one, the last part of the project, we have them compare and reflect those two. So they now have kind of results using two different, data sets there. And do they agree? Do you get the same conclusion at the end of the test? And uh, some of those reflection questions that we'll get to. All right. So here's a little bit of the snippets. I kind of cut out the actual questions, but showed you some of the, just some of the intros to all the parts of the project here. So like I said, it had this three-part structure, a previous published study, our class data, and then some comparison between the two. The main goals when they get into the project was to come up with the hypotheses, choose the test, although I kind of told them, I mean, if you look at the title, it says we're testing for a population mean. So that was very scaffolded and guided for what kind of test to use. And then we had, that third part where we're really looking at our results together. And part one and part two also have them do the interpretation within the context of each individual part there. And one thing I really tried to do, and I think we do this a lot, but try to get them to buy into this idea that it's all about arguments and building evidence, and it's not just computation. The computation is a tool, right, to help build and establish evidence. All right, so part one, where they reproduce a published analysis. So we had this study from 1992. Um, It used an oral thermometer, and we had 120, or sorry, 148 participants. And this one, we used the summary statistics. So we had a mean body temperature of about 98.2 degrees Fahrenheit and that standard deviation of about 0.733 degrees Fahrenheit. And so the students took the sample statistics there and ran that in Minitab. So they didn't have to worry about using a data set or any of the data handling, anything like that. So if you recall, this was an introduction to Minitab. So they were able to just go in, put in some numbers in a way they were similar to working with it in class on a calculator, things like that, just to get a feel for using Minitab sum, using it in a relatively familiar context from what we had done in class. And they got to go through and uh, answer some of these questions, that they had more or less kind of been exposed to already. Right. And since they didn't have to work with data directly, they were able to really focus on just the inference, getting the conclusion in context and all that kind of stuff. So, this it's kind of obvious in some ways, but how did Minitab fit in there? Well, we had our statistical question. They did all their work on Minitab, and then they got their argument at the end and their conclusion in context. And one thing I try to do is uh, make Minitab be in the background as much as possible, right? And try to keep it about the statistical questioning and the statistical argument they're making. And Minitab is just a medium to work in to help with some of those computations to achieve that. And one thing I'll just mention here at the end of part one so that we can compare later. Uh, at the For the conclusion of part one for the hypothesis test, the p-value you get is actually very low, and so we reject the null hypothesis that the mean body temperature is 98.6 degrees Fahrenheit. So that was from that 1992 study, right? So we get a pretty kind of clear result there with a really low p-value, right? So now when it comes to our data. And for this, I just did this at the beginning of class. As the students came in, I had this infrared thermometer, so you could just read their foreheads, and had just kind of went around and wrote down all of the temperatures that we got. So it was pretty quick. It didn't take long at all. I had 15 students in class, so we took all their measurements. And one thing that we'll look at here in a minute that kind of came up as I was developing the project is we're using a different instrument. So we're not using an oral thermometer here. We're using this infrared thermometer. So how does that change our measurements? And how does that change how we're going to compare our data to the claim of 98.6 degrees Fahrenheit? So kind of, are we measuring the same thing in a sense? And here was a big choice that I made, and at the end we can talk about maybe if this was the right choice or not. But we worked in this idea that there's this measurement bias twist in on top of this to kind of give the project a little more depth. So when you use this infrared thermometer, based on what I could kind of find online across these thermometers, they tend to be about zero point 0.5 degrees Fahrenheit to 1 whole degree Fahrenheit lower than oral thermometers. And since the original study in 92 used an oral thermometer, we have to, think about that, right? And so when we did our scan, we used the infrared. So what I decided to do, and I can tell you why I did it, and then we'll see if it was a good idea later. But we had a choice, right? So do we try to adjust the data, or do we adjust the claim and then see how our data matches with that claim, right, with this offset? And we also have to kind of decide how to do the offset. So to keep things simple for this project, I just took right in the middle between zero point 0.5 and 1. So I decided to do an adjustment of 0.75 degrees Fahrenheit. And what I decided to do was to adjust the parameter, right, the claim. So for this, I had them adjust the mu naught, basically, right? But we set mu equal to 98.6 minus that 0.75. And the reason why I did that, my thinking was I wanted them to really think about their data and what claim they were trying to test against. And so, since they had this data that needed this kind of correction, I had them correct the thing that they were trying to use as the claim. And I thought that would get them to think about mu being not just a number in a formula, but that number has meaning. And when you set that equal to a claim, it has to match, the context, right? So that was kind of my thinking there. It was to get them to really think about what it means to test a claim. And I'll come back to that adjustment at the end, especially in part three, and we can kind of see, how that went. All right. So, like I said a moment ago, I thought adding that measurement part in there was kind of nice to keep and not somehow kind of hide from the students because I thought it added a little bit of depth. We're comparing these studies. We'll see later, we have different sample sizes. So, how does that affect, looking at these two studies together? But now we also have this kind of measurement bias in there too, uh, just to give them, a messier situation to think about. All right. Okay, so then we get to part two, and here's where I thought the data actually turned out pretty nice because it gave us something interesting to think about. So at the end of part two, we actually ended up getting, so remember, we adjusted the 98.6 back, so we subtracted off the 0.75 and then used our data from 15 students, and we actually got a p-value of 0.075, right? So that means, and we were testing at 5% there. So that means we actually failed to reject the null hypothesis that the mean body temperature is 98.6 degrees Fahrenheit, right? And if you look at the confidence interval, which they also computed in there, the confidence interval just barely contains that adjusted claim, right? So it's right at kind of the upper endpoint there. Right, so that was kind of interesting because now we have two studies, one from 92 and then our own results and they actually give different conclusions, right? So we have some tension there, which I thought was nice to have happen so that the students had something to debate about a little bit. All right. And then we get to part three here. We have this little comparison and reflection that I set up where they write down, what were those sample statistics. The test mean there is meant to be the claim, right? What was the claim? And then they answered some things about which confidence interval, should be narrower or wider, that kind of thing. And this was the part that I think caused the most trouble. And when they did part two, they actually did okay with understanding that you subtract from the claim that 0.75, right? So they did that fine there. But when they got to here, if they want to compare these results together, you want to kind of put them back at the same spot, right? So if you're thinking of 98.6 for the 1992 study, then you want to also kind of think of the numbers as 98.6 for our stuff too, right? So you kind of have to add that 0.75 back, or you can subtract it off of the 92 stuff, right? But you have to do something to kind of put those together if you want to compare those numbers. And that kind of trips students up, and that gave them a harder time doing the comparison and reflection because they wanted to keep the 92 numbers at 98.6 and the EKU at that adjusted um, value. And then, of course, that makes it hard to compare them and see what's going on. Uh, So in this table here, it might have made more sense at the beginning to adjust the data and then have the whole project, testing against that claim of 98.6 degrees Fahrenheit. That would have made this part, I think less confusing to the students. But besides all that, let's assume that they figured that out. They're able to kind of compare the results of the two, parts one and part two of the project. Since they had a different outcome, we have some different reasons why that might have happened. One could be the sample size difference. The 1992 study had a sample size of like 148. We had a sample size of 15. So, of course, we get this wider confidence interval. Um, but it could also be that measurement offset that we used, right? Because if you actually play around within that range of zero point 0.5 to 1 degree, you can actually change the outcome of the hypothesis test, right? The conclusion of the hypothesis test, depending on which offset you choose, right? And so we, could talk about how could we make that, more rigorous? Was 0.75 really a good idea to just choose right in the middle and some of those kinds of questions. Um, all right. And let's see. And so as we kind of got around to the conclusion of it, here were some things that I had in mind. I wanted to have them really think about a parameter, and that's one reason why I did the offset with the parameter there in part two, to have them really think about that. Think about what a confidence interval is and whether it plausibly kind of includes that claimed value. Comparing the two different studies there got them to think about sample size and variability and how much those can matter. Because they got to collect data actually using an instrument, the thermometer, they got to think a little bit about how instruments and measurements are part of the whole process of, getting to a decision about data. And then lastly, try to hit home that it's all about arguments, not just procedures, and having them compare the two at the end and try to make some arguments about maybe which one they would trust more. How could they make the one that they did themselves with their own data better? Things like that. All right. And I think that kind of brings it uh, to a conclusion there as a quick run through. So maybe I'll pause here and see if anyone has some questions or things that I could revisit a little bit.
Hmm. Hmm.
I think you said this is students' first use of Minitab, right?
It is. So what I did was I actually gave them this project and they weren't in a computer lab, so most of the work was done on their own time. So I gave them the project, but then in class I had a day where they brought their laptops and we ran through just the basics of, here's where you find some things in Minitab, that kind of stuff. So we did just some small data sets and playing around a day. And then through that 2 weeks, you know, we would take a little time at various times to see like, what questions did you have? And I would show them some things in class. Yeah.
And at what point in the course is this activity?
It's really right when you get into inference, and once they have the testing for one mean is right when I did it. Yeah. So at this point, what they had done was descriptive statistics, hypothesis testing for a population proportion, and testing for a population mean. So those were and the confidence intervals that go with those. That's what they had covered so far.
But this is like three-fourths of the way through because you do probability before descriptive
Oh, that
statistics.
is a good point. Yeah, the way I did that course, there's a descriptive statistics, we do a little probability, and then we start inference. Yeah. Yeah, I wish I remember what day I did this, but yeah, that would have been, you know, certainly over halfway through the course. Yeah. Hmm.
So
And Vic,
is this a, oh, sorry to interrupt.
Or second exam material, I guess, because probability kind of goes with that first exam.
go ahead.
Oh, so I'm just curious, how many hours that you spent on this whole exercise? Is it just
You
one
mean
lecture
hours for the students or hours for me?
for you to go
For
over
me?
Class time or
the class time, I
yeah,
mean,
yeah.
the
Yeah,
class
yeah.
time?
Not that long, really. We had one day. Well, it depends on what you mean. As far as the project itself, I had a 1 day introduction to Minitab and really just, maybe 10 to 15 minutes here and there answering questions about it. As far as the content, doing the hypothesis testing, that was a whole, lesson in class that would have taken, you know, 2 to 3 class periods, to go over hypothesis testing for a mean, and then that already followed hypothesis testing for a proportion.
And
So
then did you talk about the assumptions of the test? This was a question in the chat, especially for the data collected in class.
the assumptions, just for a hypothesis test for a mean.
Yeah. Do you have students look at the assumptions and did that happen more or less with the data you collected in class?
Yeah, that was one thing that I didn't really do. I didn't go into the assumptions too much. Yeah, like yeah.
And I often use this as a transition or contrast with a prediction interval. Did that come up in your class?
No, that didn't come up. No, but that would be a nice because I think yeah, students tend to want to know what is an individual's like healthy temperature, right? Not just the mean. Yeah, yeah. But one question I got from someone was, could this be done as a lab, like within a class period? And I think it could be, except for maybe part three, where you're, maybe having more of a discussion about comparing the two. But just getting those two done, if they've already seen hypothesis testing some, it doesn't really take long to do those two tests. So I think that it could easily be done within a lab.
Any other questions?
I guess I had a question about Minitab.
Hmm.
Um, how does that, do you have that like integrated with a particular textbook or
No, no.
is it,
Yeah, it's just a separate kind of standalone thing. So, and that was part of why I worked with Beth was to come up with some projects. That was kind of the focus of what I ended up doing last semester was how do I adapt some activities for the mini tab projects. Yeah. And so this was the first one that I did.
how did you decide that Minitab was the thing
Oh,
for?
that was department. That was at the department level, yeah. It was actually my first time using Minitab in a class. So, um, yeah. Yeah, so that was set for me. Yeah. And also that structure of kind of doing descriptive, then probability, and then inference. Like that's all set for me. Yeah.
And do you have any impressions of student feedback?
Yeah, I think they really liked it. And honestly, I didn't think they had too many difficulties with part one and part two. Um, I mean, for the most part, that went pretty smooth. That idea of adjusting in part two didn't really cause them any problems. But like I said, that part three was a bit messier. Having them, um, you know, have a good take on the difference of the sample sizes and how that can make a difference. And then also with this measurement bias. Yeah. So part three was definitely kind of the uh, the stickiest spot for them. Um, yeah. Any other questions?
Alan, do you want to explain the next step?
It, did you have more slides? I know, Lance, you wanted to use
Well,
breakout rooms, and I think you have some things for people to think about and talk about in breakout rooms.
yeah, yeah. Oh, I guess I left one little slide off here. I was just thinking about how this was a good first project for me. I thought it set the tone for the inference part about thinking about claims and the context of the claim and trying to make good judgments. For Minitab, we tried to establish that idea that there's a workflow, and as we learn more inference tests, we'll be able to kind of run through that same essential workflow. Um, and then we tried to, you know, make it seem a little more realistic about how assumptions and measurements do matter. Um, and here's what I wanted to do for a few minutes is have a little breakout. And I think we have a link to the actual assignment that you can look at. And what I was hoping we could do in groups of, 4 or 5 is to try to come up with at least, one concrete way that you could adapt this, or maybe how effectively you could adopt this as an activity in your own course or context, and focus on these 3 questions here. What would you change or adapt? Why might this work for you? And then, what's one possible risk or complication or some kind of wrinkle that we might have to address?
Okay, thank you for that. I'm going to create the breakout rooms now. I think I'll set them up to go for maybe 8 minutes, 10 minutes, somewhere in
Yeah,
there.
about yeah, 8 to 10 minutes sounds great.
Give me a moment.
Yeah.
Um, all right, I think you've been invited to a breakout room. So please chat about Lance's activity, the questions he's posed here. We'll come back and talk about what you chatted about in 8 or 9 minutes.
Great.
Maybe I'll go to room 3. Lance will go
Yeah.
to room
Can I?
2.
Sounds good. Yeah. Lance, if you go to 2 and Beth goes to 3, we've got
Yeah.
Jill in 1, so
I
that'll be good.
declined for yeah, hold on. I declined for a minute and then I was gonna join, but now I gotta see how do I actually join now that I declined.
I might be able to put you there.
Yeah, all right, just put me there if you can. I've never declined a room before, so I'm like, well, how do I get back in?
Well, it don't allow me to move you. Let me move you. I'm going to move you to 1 and then I'll move you to 2. Assuming it'll let me.
Oh, yeah, yeah. Now it says join one. Can you?
But yeah,
Yeah, there
that
you go.
now I think I put you in 2. Yeah. Welcome back, everyone. Lance, do you want to put the breakout questions on the
Oh
screen
yeah.
again?
Yeah, let me share again here. Mm, there we go. Can you guys see that?
Yep.
Awesome. All right. So, yeah, so hopefully there were some ideas in there. And I was hoping maybe to get a few groups to just kind of share out what is something that you would change about it, or do you think this would be, adoptable for you? So, any recommendations, suggestions, questions?
Annalise made a good suggestion in our group about small class sizes
Hmm.
that you can, if you do this over and over from one semester to the next, you can, save data on your students and you can just add past classroom data to the data that you collect that day.
Hmm. 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 Yeah, and I've done that with other projects. Like I used to do that with a little survey I would give semester after semester, right? And you'd end up with hundreds of, people by the end. Yeah. Yeah. But this is the first semester I've done this particular activity. So,
Kind of thought it might be interesting to do a before and after the class activity at the beginning of the hour and then at the end of the hour take another measurement and save that for next class, I guess, and just see did
hmm.
most people temperature increase or decrease?
Hmm. I did mean to say that 1992 study, I did modify that a little bit because they had 148 participants, but in the actual study, they used multiple measurements per person over the course of a few days. And to simplify that a little bit, I just, imagined we had 148 people, that there were temperatures taken for.
Yeah.
So, if you wanted to make it more realistic, you could do some kind of, multiple measurements per student, but this was a beginning kind of project, so I tried to keep it on the simple side. Um,
Do a paired t-test versus zero.
well, that was another thing that I didn't follow up on, but that could come up with the infrared versus the oral, right? So, because one thing I couldn't find is the actual data for the offset for the particular model of infrared thermometer that I was using. Uh,
Uh-huh.
but we could do, if the students would be willing to do it, right? But you could do the oral thermometer temperature and the infrared per student, and for your device and try to figure out that offset. Um, and so we could then do that test later in the semester, right? Um,
Yeah.
so that would be another follow-up. How do you guys feel about which way to do the adjustment? Adjust the claim and use the data that was collected to run a hypothesis test, or should you treat the data as soon as you collect it, adjust that raw data, and then work with the adjusted data through the project? Any any kind of thoughts on which would be a better way to do that?
I almost think that doing the adjustment on the data would keep your 98.6 in their mind a little better.
Yeah. Yeah, yeah, yeah.
And then, of course, then what you would do, you could clearly then do two adjustments, the zero point 0.5 adjustment and then the 1 degree adjustment,
Hmm.
and then have those different results
Yeah. Hmm.
depending on your adjustment.
Hmm.
Well, and I think Felicia brought up in our session of just how easy the technology makes it for students to explore some of those different things and ask different
Right.
questions, because that would be really easy to just change those numbers in Minitab and make a
Right.
comparison.
Right, right, right. Yeah, I definitely, at the time, it seemed like a good idea to adjust the claim, but I'm starting to lean the other way now. Like, maybe I should have adjusted the data.
Well, but
Yeah.
it also does make the sense of the student that the claim can be adjusted, right?
Yeah, right, right.
So then that gives it more idea of it's a mental
Hmm.
comparison and not necessarily a set number.
Yeah, at the time I had that idea that, if it changed, they would see that that mu is not just like this fixed thing, right? You set it equal to a claim that you want to test. And at the
Right.
time that kind of made sense, for what
Mhm.
I was teaching and
Yeah.
doing, but um
I mean, it's tricky because of the offset. I was going to say I kind of like the way you did it
hmm.
because then with your original setup, mu still represents the population mean body temperature that would be recorded by this device if you tried
Yeah,
it on every student in campus.
right,
As
right, right.
opposed to having them right, mu represents the population mean body temperature plus 0.75 degrees, which is a
Right.
pretty non-standard way to think about a
Yeah, right.
population mean.
Right,
I don't
right,
know if
right.
you want them thinking that non-standardly in the early going.
Yeah, right, right.
So that's a defensive the way you did it originally.
And then maybe if the part three didn't expect them to kind of undo that or go back, that might have been smoother, you know,
Right.
that part of the comparison. And I would just keep in mind how nice it is to have a one sample T with an interesting number to compare to, because there's not a lot of examples of that. And so
Yeah,
that's one
yeah,
reason
yeah.
I like this a lot, even if we debate what you should compare to.
Right, right. Um, yeah, there were actually a couple of things about the way the numbers turned out that I thought were interesting. I should have had a slide up there, but adjusting for that offset, uh, it comes up to be the same mean value as the 92 study and the same standard deviation. I think it's just off like a tenth or something, like of a degree. Like, so it's really close using that 0.75 offset. So it kind of makes you feel like that's a good offset because you actually end up with pretty much the 92 study value summary statistics, right? But because of the wider, confidence interval, because of the smaller sample size, it ends up, including that offset 98.6, in the interval.
So I've
So
been
it's,
putting random links in the chat. Some are just to news articles, and sometimes I can't get to the article, but I just take the headline again to motivate the students that these are debates people are having right now. And the one I most recently posted is a study out of Stanford where they actually look at three different time periods. One, the earliest is actually back to like the Civil War, and then they have a more recent one, and then one in between. And that really seems to be where the change over time is happening. So it kind of makes
uh,
sense that you end up matching the 92, but right? Maybe why we didn't match the original ones way back
right,
when.
right, right, right. Yeah, that's interesting. Yeah,
Looks like the sample size for the study Beth just posted is 677,000. Not sure, a
yeah.
bit larger than 15.
Yeah, that's a bit larger than 15. Yeah.
But I think that's a great discussion. Like, well, anything's going to be rejected if you have that big a sample
Well,
size.
that's what I would say. Yeah, right, right. Yeah, yeah. All right. Any other thoughts on maybe some adjustments that could be made?
Okay, I counted to 10, so I guess I can talk now.
Okay.
Because in the technology, um, I'm looking at uh, changing our approach to doing Microsoft Copilot with Excel to do this a similar kind of a process instead of Minitab or whatever else.
Mhm.
And so yeah, and then also to do the randomization methods also in addition to the standard t-test. So those are works in progress.
Mhm. Yeah, that's great. Yeah,
Elise,
I've used. Oh, go
go ahead.
ahead.
Go ahead.
No, I was just saying it was my first time actually working with Minitab. I'd used R in some more upper level classes mostly, so it was a little different for me.
I do often get a lot of questions about the simulation-based approach with one quantitative variable. And one thing I like to do is kind of give them a made-up population that has the characteristics. So 98.6, and then you can pick a reasonable standard deviation. But this is one of the ones that's nice because I feel fairly comfortable assuming a normal distribution, and students seem to believe it would be a normal distribution, at least as a starting point of that population. And then we're just kind of sampling from a normal distribution, and it seems to not be as big a cognitive leap sometimes for them to think about this that way as well.
We still have some time. If there are more questions for Lance, more comments, suggestions, different ideas. While you're thinking, let me remind you of two things. One is that the recording for this session will be posted later, probably over the weekend, certainly by Monday or so. And you can find Lance's slides in the student handout online. I'll put the link in the chat again. And next Friday at the same time, Laura Callis and Jennifer McNally will be presenting an introduction to a new project and website that they've been producing, a resource for learning about student thinking and what works in statistics education. I will send out the Zoom link early next week, like I've been doing. Last call for questions or comments for Lance or anyone else.
I was just going to mention that in our just breakout room, we discussed other variables, say pulse, and
Hmm.
you could you know perhaps use a similar use the activity for regression or
Hmm.
yeah.
Hmm.
I know that there are apps that will do pulse measurements, but I might be kind of problematic to, because with the temperature, it's easy for someone to take their own temperature. I guess you could just work on having them do their pulse manually instead of using an app or something. Might take some instruction.
Well, and some people will have wearables, they'll have their watches and stuff
Mm.
that'll do it for them. Yeah, yeah. But then, I guess it's good to have everyone do it the same way, right? Because if you have that kind of mix, it gives you a little bit of, wonky results
Well,
potentially.
there's pulse emitters, right? You could just have a pulse emitter, maybe pass it
Right.
around.
Right, right, right. That's what I'm saying. Like keep it the same as much as
Yeah,
possible.
yeah.
Yeah, I've done the pulse before with having them do it, collecting it manually, all the same method, and
Hmm.
do it sitting down and then doing it standing up to
Hmm.
record two datas to talk about the importance of like a paired t-test.
Hmm. Hmm. Hmm.
Yeah, I do the pulse, students each taking their own pulse with me timing them. And we do it before and after 10 seconds of exercise
Mm.
to see how that just 10 seconds of exercise can affect your pulse rate.
Hmm. Yeah, it'd be good to, if you wanted to kind of continue, I guess that biometric kind of theme, it'd give you a uh, different activity.
Yeah, and I did just read that if you put an ice pack on your head, that the forehead thermometers will change.
Oh
So,
yeah. Well, I noticed sometimes I had to have, you have to have students move their hair out of the way and things like that, because you'll get a different rating. Yeah.
Second last call. Thanks very much to everyone for being here. Thanks especially to Lance for presenting the activity and his thoughts and comments about it. Have a good weekend. Good luck with
Yep.
the storm if you're facing a winter storm this weekend where you are.
Yeah.
Same,
Thanks
same time
everyone.
next week for another presentation in this series.
Yeah. Sorry. I just wanted to say thanks everyone for being here and